Okay, YouTube, in this video we're going to be looking at the general term of a geometric sequence. And so in our last video we kind of explored what a geometric sequence it is. We said that it is something that starts at its first term and essentially is being multiplied by the same number over and over and over again, some non-zero number. And so for instance here our first term would just be a1, but our second term would be a1 times that common ratio is what we give it a name. And we say that our third term would be a1 times r and then times r again, you know, the last thing times r again. Take it times another r, we get r to the third, and take it times another r, we get r to the fourth. Basically, the only picture that I'd like to paint here is that our first term, which has an n value of 1 here, and our second term and our third term, looking at the value of n, you know, in our term value, the power on our r is always 1 less in power than the n value or the term number that we're at here. So we would say basically the third term would be our a1 times r times r. But in other words, we could say in general, we could say because n here is 3 on our an, then the r value here is going to be 1 less than that. And so our general rule for this becomes this nth term is always our first term times r to the n minus 1 power. And so one thing I want to say here is that this is extremely, if you're asking me, similar to an arithmetic rule. It's just that the only difference here is that with arithmetic things, we're starting at a first term and then we're adding on some common difference every time. And with geometric things, we're starting at a first term and we're multiplying by some not common difference but by some common ratio. And so whereas arithmetic things multiply by this n minus 1, geometric things have it as their exponent. But we could say that in general, the nth term of an arithmetic thing or geometric thing is the first term times the common ratio to the n minus 1 power just about every day of the week. So again, to reiterate this, the nth term of something that is geometric, you will need to know two things here. Let's write these needs down. So we say needs. There are only two things you need to tell me to write this, and we're going to need to know one of them is a1. We say our first term. You must know your first term to write the rule. And then we need to know r, which is our common ratio of our sequence, okay? But if we know these things, we could basically just go plug them in for here, and we would have the rule. So that is to say, we could go ahead and write the rule of, say, these two things right here. Starting with checkpoint 2, it says, hey, find the seventh term of the geometric sequence whose first term is 5 and whose common ratio is -3. And so because we know the first term is 5, I'm just going to go ahead and write this out. And our common ratio is -3. If we were to take 5 times a -3, we would get a -15. And if we were to take that times a -3, we would get a +45, and take that times a -3, we would get a -135, and this would just keep happening and happening and happening. As a matter of fact, we were able to find 4 terms of this, and we're already up to a value of a -135. And so what I'm going to suggest is maybe it's not worth our time to write out 7 terms of this. Maybe what we'd rather do instead is just write the rule. So the nice thing about geometric things is they're quite easy to write. As a matter of fact, we know that the first term is 5 and then our common ratio is 3. Well, we have it as good knowledge here to say that our nth term is our first term times our ratio to the n minus 1. So all we're really going to do here is we're going to plug in our first term value, start at 5, and then just keep multiplying by 3's here, and we just attach an n minus 1 power on this. And so this is our rule for the nth term of this thing. What we wanted to do is find the seventh term. So now we could just say, hey, what's the seventh term? We say it's 5 times 3 to the, and I suppose we'd write 7 minus 1 power here. And so we get that a7 really is 5 times 3 to the 6th power here. And this is where we'll just get a calculator out and say, okay, well, let's see what we come up with. So we would get 5 times 3 to the 6th power. And that 6th power only deals with the 3, not the 5. So we'd say we get 3, 6, 4, 5. I believe that's how we just revealed this value here. 3, 6, 4, 5. So we say 3,645 is the 7th term in this progression here that we would have gotten to had we gone 3 more terms. So now, looking at checkpoint number 3, it says write the general term for the geometric sequence given by this, then use the formula to find the 8th term, you know, in this thing. So looking at these here, a little bit different, we're given the sequence. Again, all we need to know are a1 and our r. So a1 here, we could say a1 is just a value of 3, and then our r would be like 6 over 3. Take 6 divided by the term before, we get 2. But we'd know our a1 and our r. So our nth term would be our first term, so we're going to say 3 times our r to the n minus 1, where our r value is 2. So So one thing I do want to comment on here before we use this to find the 8th term, which is our job, is this. We never want to say that this is 6 to the n minus 1. We cannot multiply these two bases together because they aren't the same base, or at least they don't have the same exponents. So either way you look at it, it's kind of unworkable. And so with A8 here, we would get 3 times 2 to the 8 minus 1 power. And so we would get that the value of our 8th term really is 3 times 2 to the 7th. And so 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128. So we get 3 times 128. And so 384 I believe there. But check that on a calculator. But that is how we will write the rule for the nth term of a geometric thing quite quickly. Cheers.